Welcome to 5G Technology World. I'm site editor Martin Rowe. Today we are speaking with Ethan Lin of TMY Technology. Company is based in Taipei, and they have developed an interesting product called BBox. BBox is a beamforming device by which you can put in a signal and it will create the steering for that signal so that you can test antennas, materials, devices such as, well, phones or other user equipment or even small cells. And you can use that to steer the signal by changing the amplitude and phase through your PC. Ethan is going to explain how the product came about, how it works, and how you use it. Ethan, thank you for meeting with us.
Thank you for this first question. That's a very interesting history, actually. At the very beginning, there's a professor in Taiwan University. Their team, the whole group is doing antenna, especially in metamaterials. So they are trying to build up or to design antenna for millimeter wave band. But the very first question is in millimeter wave spectrum, array antenna will become essential, right, to compensate the high path loss, that kind of thing. So they were facing the issue about how to conduct beamforming at that time frame. They are very good at antenna designing. They can do the material simulation. They can design different stack up for antenna for different patch size. Even they can optimize for different bands. But the question is, how do they control phase and amplitude for every single patches? So they were suffering from that problem. So the professor tried to find out the solution. With one of our connection in between the professor and TMYTEK, the company, the people introduced, say, hey, probably TMYTEK can resolve the issue for you. So that really triggers us to think about it. Okay, that's a problem or an issue raised by this professor, but it sounds to us a common or a general issue, because there are so many antenna labs around the world. They are very good in antenna design, but they are not very familiar with active circuit, PA, LNA, or phase shifter, or even switch. Furthermore, that's only not put all the components together. You need a way to control, right? You need to offer a very good interface for people to use the facilities. So that's the trigger to TMYTEK. So we invented the BBox. That's how it has been invented like 2 years ago. So that's the motivation. We try to resolve this problem.
So what engineering problems did you have to solve to develop the BBox?
Okay, the very first thing is that because we try to create a very flexible system. So at the beginning, we are doing this for antenna people. So very first step is we have to separate antenna and active components into two pieces. But we also need to create a very innovative way so they can connect to each other easily with a reasonable loss. Because for millimeter wave band, especially for 5G, that's 28 gigahertz and 39. The path loss is relatively very high. We need to create two separated pieces, but with a very easy to use connection. So that's the first problems we are facing. So what comes to us is that, okay, apparently if we want to separate two system, connector is essential. We have to do BBox with connector. So at that time, we are searching for the proper and high performance connector for this job. And fortunately, we found that for a standard SMPM connector can be the solution. And that's come up what we have today. That's the BBox, as you can see here. They are 4x4 SMPM connectors, and all the amplify beamformer functionality were located in this small silver box. That's the connector. On the other hand, that's antenna side. So here is another 4x4 SMPM connector. So people can design 10 or maybe even 100 different antenna, but with a single and exactly the same structure, single box, so they can test the antenna easily in terms of beamforming. Yep.
Now, in your specifications, it talks about the BBox being used as a transmitter and as a receiver.
Yes.
Now, the screen image that I see on your specifications shows the transmit mode, and I can understand how that works. You can control the phase, the amplitude of, I believe, up to 16 channels.
Right.
So 16 separate beams.
Right.
And then you have some device that is receiving that signal or any of those signals. How does it work as a receiver? What does the user do? Okay.
So I might send you the latest screenshot of our GUI. That's the GUI for BBox, right? As you can see, there are 16 panels can control for each phi, that's phase, and amplitude in dB.
Mm-hmm.
So we can control each single channel independently. Here is very little tiny switch on the top left, right? And the switch controls TX or RX.
Mm-hmm.
So actually, what we do have in this silver box is a full functional beamformer. As you know, beamformer or 5G communication based on TDD, time division technology. So we really need to have a way to control the device to be TX or RX. But apparently, TX and RX, they won't work at the same time. It's TDD. So that this little switch here, once user click, they will switch in between TX mode and RX mode. Then all the controlling signal or commands will go through our API and issue the command to configure the device to be in TX or RX. That's how it works. Even better, we provide API for people. So if you want to build up your system based on our devices, you got a full functional API set. So in that case, you can control BBox by, for example, Python with C# or even LabVIEW, the kind of tools. You can control TX mode or RX mode easily. Because no matter BBox in TX mode or in RX mode, what we control is the direction of the beam, right? Actually, the beam can be in TX mode or in RX mode. It looks still like a beam. But from the GUI here, as you can see, we offer two different ways to control BBox. The first way is there's a X and a Y axis. Here's the orange dots, right? For that, we control the beam direction very easily just by dragging the orange dot and move around in any direction. In Y, for example, we can move to horizontal 30 degree, and in Y direction -10 degree. Then the beam of the BBox will pointing to that direction. What a BBox is receiving, the power will come up to here, the COM port, right? So you want to know what's the power is being received, we need to measure through this port. That's a full functional beamformer, and that's COM port, RF COM, right? So that port can be used for either in TX or for RX. It's bidirectional, there's no problem. In TX mode, we will feed, for example, we can feed many different kind of stuff. The very simple signal, for example, CW tone, the continuous wave, can be generated and feed into this port. The whole device will form the beam here and radiate through antenna here. That's whole system.
Okay. So the system, the input, if it's in TX mode, the input is an RF signal, and
it's RF signal.
It's RF.
Yeah.
Yes. Okay. And your box is doing the beam steering.
Yes, through the beam steering.
See. Okay. All right.
So that's very basic usage. Now, so that's why we create a BBox at the very beginning, because for antenna people, what they need is they need to feed RF signal and put this into chamber and characterize their antenna, right? At the beginning. So in TX mode, that's how it works. So actually, we also build up continuous wave signal on our own. We also build up our PLO, the phase lock oscillator, with very high quality. So we build up our own signal source. So for antenna people, we also will offer the signal source so they can combine two pieces together to test the antenna very easily.
I see. But you could also put in a modulated RF signal if you wanted to.
Yes, of course. Yes, exactly.
Okay. Now you said that the unit covers 24 gigahertz and 39 gigahertz.
Right.
Okay. Now will it cover that range with any of your antennas? Those frequencies?
Oh yes. So I thought that's your next question. I personally I thought that's a very good question because that's a very key part of the device. From our specification of the device, we documented it as supported from 25 to 31 gigahertz. That's super wideband. That's what I'm talking about. This box.
Yes.
All the devices here, the power amplifier plus low noise amplifier switches and phase shifter, they all support that wideband. So we claim this 25 to 31 of this one. But your observation is exactly and very precise. Now, the bandwidth limitation was here. That's very wideband. And that one, the official antenna kit we offer is in the band. We call it N and 261 in 3GPP. Yeah, 261, N261 band. That would be like a 27 something to 28.35.
I see.
That's the bandwidth we optimize for this specific antenna. But for other research groups and other companies, they might be interested in different band. So they can, optimize in their antenna in different bands and connect to the same box here.
So users might develop their own antennas and connect it to your box.
Yeah, that's the first target audience. They are antenna developer. The one thing
I
I
see.
should mention about that, there's another challenging to design and manufacture such kind of device. Because if we want to support very wideband, then we have to guarantee the phase and the amplitude control will be equally, precisely in different frequency range, right? If people they want to use then to design antenna based on like a 26 central frequency, then we need to offer precise control tables for them in that band. So how to calibrate the device precisely and quickly, that's our know-how. We build up the device with our many hardware and software effort to achieve that.
I saw on your specs that the BBox, when it's using the 8x8 array, the steering angle seemed to be plus minus 25 degrees, as
Right.
where the 4x4, you have an angle of 60 degrees. So
Right.
Why is that?
Usually, as you can see here, we have 4x4, there are 16 RF ports. That means we have 16 sets of PA, and phase shifters. So in this case, to achieve the best steering angle or to maximize the steering range, we need to use one RF port to control one patch. That's
I
the
see.
case.
Yep.
One maps to one, then in that case we have the widest scan range. But we also find out in some application, people need maybe they don't care about the steering range that much. They care about the beam width. So with a larger array, more array size, we have a narrow beam. The beam width is narrow, it's smaller.
I see.
Yeah, so that fit into different application scenario. So, but just like I mentioned, this one we created for R&D purpose, for research, for institute, for an R&D department in a company. So all this trade-off, we thought that's reasonable and can offer people to use the device in different scenarios. We choose 4x4 because we thought that's the basic unit size for small cell or for CPE.
I see.
Yeah.
Okay.
So probably people can explore enough the characterize and how the millimeter wave propagation properties just by this setup. Yeah. Like I mentioned, BBox, we originally designed for antenna designer, and that's very good and very flexible. But very soon we learned that's also an awesome tool, a great development platform for protocol and algorithm developer. How would I say? As you can see, we can feed a modulated signal here, right? And actually, we are also very good at building up-down converter. Also a very wideband and very broadband up-down conversion. We supported it from 24 to 44 gigahertz in RF. And we can do IF, the intermediate frequency in between DC to 14 gigahertz. So with BBox and up-down conversion here, and the baseband unit, so people who want to develop a 5G protocol or in beam tracking algorithm, or even want to try out the taste of analog beamforming plus digital beamforming and to do a hybrid beamforming. So nowadays, we already shipping many sets of devices around the world, and people is doing 5G. Some people is doing even a radar application based on our setup, and other millimeter wave sensors. since we are good at building BBox and UD, the up-down conversion, we actually have the technology to build up everything in this single little tiny PCB package. So all the functionality I mentioned on BBox and up-down conversion has been built up in this very compact device. And the technology based on is antenna in package. We call it AIP. In low Earth orbit, satellite communication, and in many, many other applications.
Well, Ethan, thank you very much. I wish your company very well. I think you have a very interesting product here, and I hope you
Yes.
do very well with it.